Welcome back, everybody. We are still on section 7.2. Today we're going to talk about the explicit formula for an arithmetic sequence. So we have our formula here. The a sub n means what term you want to find. So if you want to find the 11th term, that would be a sub 11. If you want to find the 9th term, then it'd be a sub 9. If you want to find the 202nd term, then that would be a sub 202. Whatever value you put in for this n is the same as this n in the formula. So again, if you wanted the 11th term, then that n would be 11 minus 1. If you wanted the 9th term, then it would be 9 minus 1. If you wanted the 202nd term, then it'd be 202 minus 1. A sub 1 is the first term. Oops. Of your sequence or your list of numbers. And then the D is the common difference. And that's what we talked about in the last notes for this, where the common difference is that value that you are adding or subtracting every single time to get from one number to the next in your sequence or your list of numbers. So finding the terms. They're asking us for two things. They're asking us to find the 13th term here. And then a sub n is just it's called a rule, which is basically the equation that we use to find any term. So we'll start with finding that general rule or equation, that a sub n, and then we'll use it to find our 13th term. So we're using the formula that we just talked about on the last slide. Starting with a sub n, because again, we're doing our general rule first, sorry. A sub 1, first term is -3. So we replace a sub 1 with 3 plus n minus 1. Remember, we only replace the n if we replace the end over on the left side. And since we're just finding a general equation right now, our n is going to stay in there. N is kind of like x. And then we need to find the d. What is the rule that we're using to go from -3 to 1 to 5 to 9? And it looks like +4, +4, +4. So our d is +4. I'm going to clean up this equation by distributing the 4. And then combining like terms. So we have 4n, -3 minus 4 more is -7. So this is our general rule, or how we're going to find whichever term number they ask us for. Now that we know this, we can find our 13th term. So we say a sub 13 is equal to 4 times 13 minus 7. I'm going to use that new rule that we did, that we just made, to find this. You can also plug it into the original equation, or the original format of a sub 13 is equal to -3 plus 13 minus 1 times 7. Or sorry, 4. I don't know where I got 7 from. I apologize. So that's plugged into the formula that we just talked about. The one on the left is plugged into the formula that we just made. We do 4 times 13 is 52. 52 minus 7 is 45. So the 13th term, or the 13th number in our list of numbers, would be 45. For the second part of example 3, they again want us to find two things. They want us to find a general equation for any term number that we could possibly want to find. And then they also want us to find the 16th term, or the 16th number in that list of numbers. So I'm starting with the general equation first, leaving n alone. Our first term is 23. Remember, we leave the n in there because we aren't finding a specific term right now, but we do need to find our d. So what rule are we using to go from term to term to term in this list of numbers? 23 to 20 to 17 to 14. And so if I'm looking at that, it looks like we're subtracting 3 each time. So our d is -3. So I'm going to put -3 here. I'm going to simplify this equation. Start with distributing that -3. So 23, -3 times n is -3n. -3 times -1 is +3. Combine those like terms there. In my general equation, we have -3n. 23 plus 3 is +26. That's the first answer that they're asking us for. Now they're asking us for the 16th term. And again, we can plug 16 in for our n values in this equation right here. Or we can plug 16 into our n values in the general equation that we just made. I'm going to plug it into our general equation that we just made. 16th term, n is changing to 16. So this n after the 3 is changing to 16. And when we do -3 times 16 plus 26, we get an answer of -22. So the 16th number in our list of numbers, if we continued writing it out, would be -22. That's where we're going to stop for today. Thank you very much, everyone. See you next time.